Okay, so this video is for Mrs. Cucci's College Now Pre-Calculus class. This is where we left off for lesson 2.3, where we were talking about composition of functions and then finding the domain. Now, we did page 1.16, but I needed to go back and take a second look at this on finding the domain of the second function g of f of x. We found g of f of x to be, let me see here, where did we put it? We found it to be 5 over 1 over x minus 2. And when we were talking about this, we did the whole keep, change, flip, and we found it to be a nice linear function. Now, what I didn't pay attention to when I was doing this, and I apologize, is when we're talking about the domain for this, this original function does have a value at which the function is undefined. And we know this because if you look at this denominator, there's a value of x that's going to make this be undefined. So we have to be cautious with that. So I know that we said our domain was all real numbers. I need to do a retraction here. I apologize. Our domain is going to be everything from negative infinity to 2. And then 2 to infinity. So it's everything excluding the value of 2 because that value makes our function undefined. Okay, so what I want to talk about now is something called decomposition or decomposing a function as a composition. So when you get to calculus, you'll need to be able to recognize how a function can be expressed as a composition of two other functions. So essentially, you're going to need to be able to look at a function and decide how you can pull it apart to make two separate functions. Okay, so let's take a look at the first one. I've got h of x equals 2x minus 3 raised to the fifth. We're going to find f of x and g of x such that h of x equals f of g of x. So what I want to do is I want to take this h of x and pull it apart and make two different functions from it. So that if I were to take those two functions and do the composition, I would wind up with h of x in the end. Okay? So we're thinking we need something for g and then something for f, right? Now, if we look at this, we know that g is going to have to go into f. So what I'm kind of thinking is if we have this function, 2x minus 3 to the fifth, what if this 2x minus 3 were just x? Okay, so what we're going to do is we're going to say, we're going to let f of x be x to the fifth. If f of x were x to the fifth, g of x would have to be 2x minus 3 in order for the composition to work. Okay? And the way we test that is by simply doing the composition. F of x is x to the fifth, g of x is 2x minus 3. We want to find f of g of x, which means g has to go into f, which would give us 2x minus 3 to the fifth. Okay, so it does work. The decomposition does work. So our decomposition, our new g of x is going to be 2x minus 3, and our f of x is going to be x to the fifth. Now, are there other ways to do this? Yes, absolutely. This is just the one that popped in my mind the fastest. Okay, so there's multiple correct answers. Okay, so if h of x equals 1 over x plus 3 cubed, find f of x and g of x such that f of g of x equals h of x. So again, you're always looking at what you can replace, right? So this is kind of always what pops out to me. I can replace that. So if I were to say that f of x equals 1 over x cubed, g of x, in order to make that composition, would have to be x plus 3. Okay, so you're simply pulling them apart, making two different functions. That's when you take the composition, they wind up to give you back that original. So you're kind of looking for things like that. That would make substitution easy. Okay, so we're going to do lots of practice with that in class, and you're going to get very comfortable with pulling apart those compositions. So incredibly short video tonight. Hope you enjoyed it, and I'll see you tomorrow. Bye.